All right, so what we're going to be doing is we are going to be moving a set of Rhino Geometry into a Revit file, and the workflow itself is going to be relatively compact. This is the kind of workflow that we're looking at, and you can think about it as a couple of sort of sections. There's a portion at the beginning of the file, which is these 1, 2, 3, 4, 5, 6 nodes that actually fetch the Rhino file. There are these 6 items here which actually just take it and dice it up into floor planes. And then there's a handful of nodes over here on the right which are the Revit specific nodes which are going to take that geometry and actually create Revit Revit elements out of it. And just to sort of show you again where we're headed with this, there's a file in the folder that you can open up and just sort of see again where we're going to go. So Rhino to Revit Walls, and there's also a completed file of Rhino to Revit Walls.dyn, which will reproduce this workflow if you get out of sync. So the starting point, again, is going to be a Rhino file, which you don't need to have Rhino installed in order to do this, but you do need to download the Rhynamo package for Dynamo, and I'll show you how to do that if you don't already have it. Oh, Colin, do you have the license open?
I do. Sorry, hold on.
All right, no problem.
Okay. All right, there you go.
So while you folks are seeing me set this up, I just want to make sure that you're getting a chance to download the package. So I already have Rhynamo installed. You're going to need to go to the package manager and search for a package. And after it syncs, just type in Rhynamo, or you can do Rhino and it'll come up too. Download that package and you'll be good to go. So it's just Rhino. So you're going to grab that guy and off we'll go to the races. And so the plan here is I'm going to start from, hopefully I've got the license now. Yep, there we go. Workflow here is, imagine if you will, you have people on your team who are working in Rhino, as many of our customers are. They have some initial design for a project. They want to be, moving this data directly into Revit. How do you go from this kind of thing into a Revit file without just doing sort of a dumb sort of export to SAT file and plop it into Revit, which is what a lot of people do right now. So in order to get set up to do this, we're actually going to make just a new architectural template, but don't just grab any old thing. You need to start off with an imperial template, and I'm just going to grab the commercial default. The reason that you're going to want to do imperial is that the design in Rhino was assuming dimensions. I think that the whole building is 60 units wide and about 50 units tall. Rhino has sort of a different relationship to units than Revit does, but if we opened it in a metric template, you would end up doing things like you would turn it into a 60 millimeter wide building, which is probably not what you want. So when you have your basic starter template, you can take a look at that file that is in this folder, which is Rhino to Revit Walls.dyn. Again, this can be a catch-up file. What we're going to do is we're going to recreate this from scratch. But if you want to just sort of take a peek at it, oh no, it's running in. Oh no, it's not running in automatic. Okay, I thought it was doing it suddenly spill out all of my geometry. Again, I just want to inspect it a little bit, and then we're going to build this guy from scratch. So again, left-hand side has the Rhino nodes. The right-hand side has very specific nodes for creating Revit stuff. It's creating levels, it's creating floors, it's creating walls. And in the Chewy center, we've got just the operations to cut this geometry up into floor planes. All right, that is our setting. I'm going to do a new file, and we're going to do this from scratch. So the first thing that you want to do is we're actually going to want to get the Rhino geometry. You'll notice that it's not just a operation to just go and read the whole thing and dump it in. The guy who put this together, Nate Miller, had a very specific sort of attitude about how you work with Rhino files, and that is generally these files, when they're in production and when you're in an office, people put a lot of detail into them. And so what he's done is he's allowed users to go in and actually scrub them a little bit so that they're a little bit cleaner, so that you're just getting the information you want and not all the extras. We're going to be dealing with a fairly simple model, so you kind of lose that flavor. I'll probably make a more complicated one in the future so that people can appreciate that aspect of it. So getting the basic file. This is going to be very similar to what we were seeing with Excel, where it's going to be a file path where we're going to browse to the object, and we're also going to do the file creation from path. This one is a little bit funny, but again, as Colin was saying before, the reason that we have this node is basically to allow people to sort of do live updates. Essentially what you can do once you have this sort of little trifecta set up is that you're going to be able to read the file live from disk, so you can also edit it in Rhino if you have it or if you want it. So of course the first thing that you're going to want to do, you want to browse to that file location, wherever it is on disk. For me, this is where it is. You can go to that file. I can get my envelope curve.3dm file. It gets bigger. I complete my file from path, so now I'm getting that file object. So now I'm going to be watching that thing, and I can live update it if it changes. And then I'm going to wire it into my get Rhino file. So the outcome of this now is that I've got a bunch of information. This is also, like, there's a lot of things in here about how to maintain sort of knowledge about what's going on in the Rhino file without even having to open it. So again, you can use this without having Rhino on your installed on your machine. The next thing is that you're actually going to get some specific objects out of it. So, and also, by the way, when you get these sorts of packages from people online, you can also look at, usually they have sample files. So I didn't make this up. I didn't just open this up and figure this out. If you go to Manage Packages, the installed packages will be listed here. So I've got a bunch of different stuff. And if I click on here, I can say Show Root Directory. And this is basically all the stuff that I got from the package manager. And if I look in Extra, there's actually a couple of sample workflows. And a README, basically the package creators, if they're good and if they're really polished, what they're going to do is they're going to give you starter workflows to look at. So you don't have to just start from nothing. Anyway, just a little tip that you can go and find out that information about Rhino. So from the Rhino object, I'm going to get the document object. So again, this is one more step where you can start sort of narrowing down the pieces that you need to get out of your file. It's giving you a lot more information about the file again, so that, you know, if you don't have Rhino, if you don't have it, you can actually be interrogating the model to find out more information about it. Finally, we're going to get to the point where we can start actually getting geometry out of this thing. I know because of the way that I made this that the object that I'm going to be looking at and that I'm interested in is an extrusion. Again, with the idea of getting specific kinds of information out of the Rhino file. What the creator here has made is a bunch of, again, very surgical tools to extract information from the model. I can get all the geometry. So you can see here, Rhino, all geometry to DS. This would get all of the things, points, curves, B-reps, extrusions, meshes, that would be possible and accessible from this file. I happen to know that it's an extrusion, so I'm going to actually be a little bit more surgical about it, and I'm going to grab just that extrusion. And you'll see it now it's thinking about it a little bit, because now, Shazam, we've got actual stuff out of this thing. The other thing here is that because I was surgical about it and because I decided I was going to get just the extrusions, there's a bunch of other information that I can extract from this, colors, GUIDs, that sort of thing. So again, handful of nodes here, and what I get out of it is this set of geometry that I can rely on. If I drop in a watch node here, I can also just look at what I've got. It's polysurface. Polysurface is, again, for those of you who are new to sort of computational geometry, a polysurface is, many surfaces. It is a collection of different surfaces that have been sewn together into a single object. That's what a polysurface is. One other thing, Colin has been talking a little bit as we've gone through this about lists that have items in it. There might have been many extrusions to extract from this file, so by default it puts it in a list. It happens that there's only one thing that I'm getting out of this. So I can just isolate that by getting the first item. If I type in first, there's a couple things that show up. Deconstruct is kind of a funny one, but first item is really what I want. Deconstruct actually puts together the functionality of first item and rest of items into a single thing to basically start breaking apart lists. I could use list deconstruct. I could use item. There's also some design script shorthands that I could use to do this same thing, but I'm just going to use list first item to get that piece. So now I'm just dealing with a single polysurface. So there's that first part of our sort of three-part project. So I'm getting my geometry out of Rhino. And another thing just to sort of point out about this workflow, again, the sort of surgical operations that Nate put together here to get very specific things out of your file, those are also things that are available in these other nodes to just say either I just want to look at specific layers or I just want to find out specific layers that exist. You can do a lot of interrogation of a Rhino model with these tools as well. So it can be a pretty powerful tool. But at this point, I can actually put all this stuff away, and I actually don't need to think about Rhino right now. Now I've got basically my entry point to dealing with it. So now, what am I going to do with it? So if I've got my shell for my building project, the end goal here is that I want to cut it up into floor plates, and I want to put some Revit stuff in it. So the first thing I'm going to want to do is I'm going to actually create planes to do the cutting. And I know we did a bunch of stuff with geometry yesterday, so I want to sort of quickly go through this to get that geometry out of it. And again, I'll go a little bit quickly here, but if you need to catch up, you can just open up that file that was included in that package to get along with it. So the thing that I'm going to do is I'm going to create planes in order to cut this piece of geometry. And planes are created by generating points and giving them normals. So it basically needs a place to start and a direction to point. So our good old friend from yesterday is point by coordinate, which is, here we go. So this will create a single plane that I can cut with once I also give it a vector. So the normal is a direction. Normal is another way to say the direction that this is going to point in. So if I go to my geometry library, I can also browse to vectors. There's a couple of convenience methods here for vectors. So I could construct a vector out of inputs like this and say, I want to point up in the z direction. That will give me basically a pointer in the upward direction. I can also just get my z-axis, which does the same thing, and it's just a little tidier. So there are many ways to do the same thing, and some of them are a little bit more efficient than others. So now I've got my plane, and you can see that right here. Plane is represented by sort of what you've given it, which is the flat area that is defined, and then the vector that you've given to also define it with that point. So that is essentially my first cutting plane for making my floors out of. Of course, I don't want to just have one. So what I'm going to do is I'm going to use the code block, the range syntax tools that we were learning about yesterday. I'm going to start a little bit off the ground. So I'm going to start my range at 1. And I'm going to say I'm going to go up 50 feet. Again, Dynamo is unitless, but Revit is not. So remember that Revit is going to be expecting things to be coming in imperial units. So I'm essentially giving it 1 foot to 50 feet, as opposed to 1 millimeter to 50 millimeters, which would only make sense if I was making a very, very small dollhouse. This would give me 1 to 50 in single increments of 1, the way that it's set up right now. If I add another dot dot, I can then say I want to do it essentially in my floor to floor height. So I can say 10. Say 10 is a nice sort of normal floor to floor height. And then I pass it into my Z, and what you see is that now I've got a bunch of floor plates, or sort of proto floor plates. These are going to be my cutting planes. Okay. So I got my geometry coming in from Rhino. I've got my floor plates that are coming straight out of Dynamo. And basically I need to intersect them. I need to intersect these pieces with each other. Again, this is just you can either search for it, intersect, the geometric operation of intersect. It's not the first thing that comes up, unfortunately, but it is in the short list for geometry operation. Again, we spent a bunch of time yesterday talking about geometry operations, so I'm not going to get too much into the structure of this, except to say that intersection is something that you can do with all geometry, so you can go and look in geometry for all the things that you can do with it. All those sorts of Boolean solid operations like intersections, unions, mirror operations, those are all in the geometry subcategory of geometry. So I'm going to take all of my planes and I'm going to intersect my poly surface, and easy as that, I get a bunch of blue lines that show up that are actually the place where those planes intersect with that geometry. Another thing that you can look at here that's kind of interesting to see is that there's actually, this is not immediately apparent, but there's another workflow I can show you where you can see the value here. Because I'm extracting a fairly high-grade piece of geometry from Rhino, that is, I've identified it as an extrusion, I know the kind of characteristics of it. As I do other operations on it, a lot of those characteristics come through. So for instance, this isn't just like a NURBS curve. These aren't NURBS lines or splines or anything else. It actually has identified that this is an arc and these are lines. And that's important because if you go into Revit, you'll see things like if you want to go in and draw a wall, you will see certain things that you can draw. Among them, you don't see a spline. Revit doesn't draw B-spline walls. It draws arcs and lines, and it's actually going to be limited by that same thing when you get into walls. You're actually going to need to pass arcs and lines into the wall creation tool. And so because I was able to operate on the Rhino file with this kind of fidelity, I'm actually going to be able to work with this geometry in a pretty easy way. All right, so now I've got, oh, sorry, one second. Lost my notes for a second. So now that I've got my curves, basically I need to turn this into Revit stuff. When you're making Revit stuff, most of the time what you're doing is you're either clicking or you're doing 2 clicks. You're placing a thing or you're drawing one segment of a wall. And Dynamo is really just a very, very busy user of Revit. So we're actually going to use this to do the same thing. We're going to use these pieces of geometry to click in the canvas essentially a bunch of times to make Revit geometry. The first thing that we're going to do is we're going to make floors. So if you go into the Revit tools, elements, we're going to make a Revit element. What kind of Revit element? We're going to make a floor. So we can say floor. You can actually use either one of these. There's 2 different methods. We're going to do a floor by outline polycurve. I think you can actually use either one of these here, but I guess we'll just use polycurve for now. And what I'm going to do is I'm going to look at the data that's coming out of here. I'm going to look at the data that you need in here. So I've got a bunch of lines, which are going to form the outline of this thing. And I've also got some needs around creating floor types and levels. So let's start with the floor types first. So Revit, in order to make floors, is going to want to have floor types. When we were looking at different selection tools before, there were sort of systematic ways of grabbing things like all elements of category and all elements of type. There's also ways to select different things that are already embedded in the file. Like if I had family types, I can go and look at, here are all the families that are loaded into my project. I can also look at all of the floor types that are loaded into my project. Similarly, I can also look at wall types, and we'll get to that one later on. So if I'm looking at my floor types, I can choose a floor. Let's say I'll get a generic 12-inch slab. And I can wire that guy into my floor type. I'm also going to turn off Run Automatic at this point to manual, just because I'm going to start making Revit stuff, and I want to be a little bit more purposeful about it when I start to make it. So now that I've got this, I also need levels. So for each one of these floors, I need to assign it to a level. I don't actually have any levels in this floor other than the ones that are available in the template. So I actually need to create levels as well. So there's a tool here for level selection, which just gives me a list of the levels that are already in the project. But that's not going to be enough because I'm actually creating a level for each one of these floors. So again, because I'm creating stuff, I'm creating Revit elements, I can go to Elements and Level. So if I look in this, there's a few methods that I can have in order to create levels. I'm going to take the simplest one, which is just by elevation. So here, if I give this node a number, it will create a level at that number. It so happens that I have a list of all of those numbers here because I created all of my sort of fake floor planes for my planes. I can actually use that same set of data to create all of my levels. You can see what spills out of this when I run it, because I turned off Run Automatically, that now I've got a bunch of levels that get created. Very convenient. So now I've got all of my levels that I can pass in. here. So now I just have one more thing to do, which is to create all of my floors by the outline. Now, what's coming out of here, and this is another list manipulation thing, is could be a little bit tricky, but actually what the floors want is they want a continuous outline for each one of these plates. So what I'm going to do is I'm actually going to collect all of these collections of curves into a single object. You can see this is looking for a polycurve. So I'm just going to search for polycurve. And I can create polycurves. There's a bunch of different ways that I can do that. So in the polycurve creation, I can create them by joined curves. And then again, if you wanted to browse to that, you can see where it is. It's in polycurve create under the geometry tab. But just to sort of get that sort of muscle memory of knowing where things are kept, you can look for polycurve, and you can just look at the creation methods for it. So all I'm going to do is I'm just going to take each one of these lists, and each one of these lists is going to be its own contained polycurve. So I'm actually going to get a simpler set of information here. This is one of those places where actually as you work through your graph can actually get simpler as you work with it rather than more complicated. So if I run this definition now, I've gone from this list of lists into something that's actually a little bit more comprehensible. I've taken all of these collections of curves and I've stuck them all into polycurves. So each one of these represents the outline of a floor. So now if I pass this, what I've got is I've got all of my information going into the same place. And it's also something where I don't have to get into list combine or any sort of fancy maneuverings for lists because everything lines up. I've got 1, 2, 3, 4, 5 polycurves for my outlines. I've got 1, 2, 3, 4, 5 levels. Everything's copacetic. So if I run this guy, it's going to think for a second. Oh, did I already do it? Oh, it doesn't even think for that long. And Shazam, I've got a bunch of floor plates. So these aren't import instances. These aren't, dumb things. These are actually floors that have real floor qualities and will cut like floors and label like floors and do all the things that Revit expects from them, including, scheduling and all the rest. Also, Dynamo can go away and not be involved with it at this point, and other people in the project can work with this file. Well, let's do one more thing. Let's make some walls out of this thing, and then let's call it a day with Rhino. So last bit. We're going to make some walls because buildings like walls. They're Revit walls, they are Revit elements, and they are walls. And I'm going to make it by curves and height. There's a couple different ways that you can make walls. You can give it a start level and an end level. What I'm going to do is I'm going to just give it a bunch of curves, and I'm going to say how tall I want them to be and what level I want them to be on. And right here I can just say I want them to be 10 feet because I know that that's my floor-to-floor height. I could also just bring over that 10, but I don't need to be that fancy. So I can start filling out the information here that I know of already. It wants levels. It wants wall types. So I can go over here into, this is another selection operation. Wall types. It looks inside of the model and it says what kind of wall types are in the model. All sorts of kinds. So I can just start off with something simple. Just give it a regular, they're all going to be that wall type. I could do other operations to make it a little bit more complicated, to say give myself a different kind of wall type on the floor, but for now let's just keep it as it is. And then this is where things are going to get a little bit more interesting, and very much in the way that Colin was showing before with list combine. What we've got here is we've got two lists coming in here. Walls don't take polylines, they take curves, because remember, walls are a method where you create things like this. You go click, click. I'm drawing two things. These two walls together are not one thing. They're each two separate things. As opposed to a floor where if I look at this, this is a collection of curves that Revit is using as a collection, and it wants them to be collected into one thing, and that's why we used a polycurve. Walls are a little bit different, and Revit wants different stuff. It wants a collection of curves. So here I've got a situation where rather than having even lists, like I've got a polycurve and I can map 0 polycurve to 0 level, I'm actually going to have something that's a little bit different. I'm going to have a bunch of levels that I want to combine with a bunch of curves coming out of here. So this is actually going to be a place where you're going to need combine again. Another way to think about combine is it's like zipping 2 collections together. So if I took all of my curves, so this is what walls need to be. Walls need to be a series of curves that are all fed together. And I take my collection of levels. This is where I'm making my matching. I'm saying each one of my levels is going to go with each one of these collections of walls. So I'm sort of doing some of the brain work of matching those lists up before I pass it on to a wall. Because over here, I've got a different set of things going in. I've got single wall types. I've got single floor heights. So now we're going to do the passing function dance again, where now that I've got my lists organized together correctly, they're zipped up into one nice little package. I can take my wall, I can pass them to combine, and when I run this, it's going to think about it for a second, actually not even that long, and you get a nice set of real Revit walls. Of course, why make it simple when you can make it complicated more easily? So storefront always looks a little bit nicer. It takes a little bit longer to run, but you can now swap those things out. I already created some walls, but now maybe I want to modify them and do something else with them. You can see it takes a little bit longer for it to regenerate. Crunch, 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 crunch. And so now what I've got is the full Revit file that has a bunch of floors, a bunch of walls, and it's all linked live back out to my Rhino model. So I can go back out, I can modify my Rhino model, and I can know that it's going to be passed down through this whole chain of command to still work with the rest of my Revit file. I'm going to take a pause there. Colin, I know you've got to go, so I want to say thanks for coming, and we'll catch up later. And I want to just open this up for questions because I want to spend a little time doing troubleshooting and debugging methods, and then still have some time for questions afterwards. So any questions on this particular workflow that we just sort of hustled right through?